Hello everyone. We're going to continue now our discussion now. So we're done with this problem now. Okay. We now proceed with our next topic. So we're done with manometers. All right. So we have here. So before I proceed with the next topic, let us have a review concerning certain topics that you have studied in the past. Maybe it's not it's not new to you, no, for some. So, but for some, maybe they these are already known. No? So let me start with so we have here area, centroid, and moment of inertia of common figures. So you have studied about area, okay? So then centroid, in calculus, this was taught, no? So this is a topic in calculus, no? So and then we have moment of inertia. It's also a topic in calculus and engineering mechanics, no? So I don't know if you have studied these two concepts, no? The centroid and the moment of inertia. So let's start with the rectangle. So we have a rectangle, okay? Now consider this rectangle having a base B, or should I say length B, and width A, no? Length B, width A, okay? Or should I say base B and height A, or altitude A, no? Now in this case, the area is known as the product of the length and the width, no? So base times the height, or base times the altitude. So we have BA. So that is common, and most of you already know this, right? Then we have here the centroid. Centroid C. So it is a point located at the center of an area. So we have what we call a centroid of an area. It's the center point of a certain region. So in this case, we have this area of a rectangle. So this is the center point of the whole area of the rectangle. Okay. Now with that, so we call this center point as the centroid. Okay, centroid of the area of a rectangle. Okay, C is for centroid. And for the centroid, okay, if we are to measure horizontally, no, from the end from one end of the rectangle to up to the centroid, no, horizontal distance. So we consider this horizontal distance to be one half of the total length of the rectangle, one half base, no? So this is the centroid, no, of the rectangle. So the x, that's the x component of the centroid, no? It has also y component, no? So we have the y coordinate. So we have the centroid xc, no? So this is now one half b. If this is the point 0, 0, okay, the origin, this is the origin, okay, and we consider this as the x-axis, and we consider this as the y-axis, okay. So this is one half b. Same as here, we have one half a, okay. It's one half of the total length of a, no, for the rectangle. So that is one half a. Alright? So that is xc, yc, the coordinates of the centroid C. Okay? So we have the x coordinate, one half b, and the y coordinate, one half a. So from this position up to the center C, this horizontal distance is one half of the total length of B. No? Vertically speaking, so this is the total length vertically is A. So this half of that length, no, is the distance, the vertical distance from the origin to the centroid, no? So this is one half A, no? From the origin up to the centroid, vertical distance, one half A, okay? So, so we proceed. Now, we have what we call as moment of inertia. So this is the formula for moment of inertia, okay? If our figure is rectangle, okay, the moment of inertia formula for the rectangle, no, is this one, IXC. So we have IXC equals one half BA cubed, no? So that's the moment of inertia of the rectangle. Sorry. Let's go back. Alright, so this is the moment of inertia of the rectangle. Now, so that is one half BA cubed, no? 1 over 12 BA cubed, no? So moment of inertia of a rectangle. So 1 over 12 BA cubed. So what is moment? So this is a topic discussed, a topic that should be discussed in engineering mechanics and calculus, no? In calculus 2. So this is the moment of inertia, no? Uh, about the centroid, no? About the axis, where the axis passes through the centroid, no? And that axis is parallel to the x-axis, no? It is parallel to the x-axis. Okay? So we have here IXC is the second moment of the area. Okay? So we call IXC is the second moment of the area. So this is also known as area moment of inertia. Okay? Area moment of inertia. Okay? So with respect to an axis passing through its centroid, no? So there is an axis that passes through the centroid and it is parallel to the x-axis. Okay, so that is IXC. So I will show you later how did we arrive with this formula 1 over 12 BA cubed, no? So that you can able to understand moment of inertia, no? So for those who are who did not encounter this before, I will give you a short I'll give you a short review, no, regarding this topic. So we have here, so it is defined as, so the moment of inertia of a plane area is a property of a two-dimensional plane shape, no? So it is a property of a two-dimensional plane shape. So this is two-dimensional, right? So it has length and it has width, this rectangle, which characterizes its resistance to deflection, no? Which characterizes its resistance to deflection under loading. Okay? So when we apply a force, in this area, no, when there is force acting on this at some part of this area, no, so there is a tendency that this area will deflect, no? So if this is an object having this area, it might deflect, no, because of the load applied, no? So pwede siyang mag-move, ma-turn. Kapag merong force na in-apply, pwede siyang ma-turn. Okay? So, ngayon, merong property yung bagay na nire-resist niya yung pag-turn. Pinipigilan niya yung pag-turn. No? Okay? So, ang property ng bagay na yan ang tinatawag na inertia. Okay? So, moment of inertia. No? So, yun ang property ng bagay. Okay? Para mapanatili niya yung kanyang initial position. Okay? So, in this case, for moment of inertia, when we apply a certain force at any position, no, in this area, okay, so yun ang loading. So there's a tendency that it will turn, no? Pwede siyang matwist, no? There is a tendency that it will twist. And the material, no, has the ability to resist that force applied so that it will not twist, no, para hindi siya ma-turn. May property yung bagay. Ang tawag sa property ng bagay na pinipigilan yung pag-turn, no, ay moment of inertia. Okay? Alright, so I will give you an example to this, no? Okay. So here's the derivation, no, of moment of inertia of area of a rectangle. So just to give you an idea of what is moment of inertia, no? This is not part of our syllabus, no? Hindi siya part ng ating subject, no? Pero kasi dapat naaral nyo na to sa engineering mechanics at saka sa calculus. Topics yan sa calculus and engineering mechanics, no? So, pero baka kasi hindi nyo natalakay. So, I'll give you uh, a short background, no, about this moment of inertia topic, no? Okay. So, suppose we have here the x-axis and the y-axis. And we have the origin at 0, 0. So our goal here is to derive the moment of inertia of the area of a rectangle. Okay? So papalitawin natin yung 1 over 12 BA cubed dun sa moment of inertia, no, about the axis passing through the centroid and parallel to the x-axis. No? So, suppose ito yung ating area ng rectangle. Okay? Now, it has this height, which is A, no? Or we can call it as width, no? It has also length B or base B. Okay? And sabihin natin, ito yung origin at ano yung coordinate natin dito. Kung ito ay A, so madadagdagan yung 0 to ng A. No? So magiging Yung 0 na to, madadagdagan ng A. Tataas ka. So, this is now 0A. No? So, sabihin niyan, yung distance mula sa origin hanggang sa taas ay A. So, this is now the point 0A. Okay? Tapos, meron ka ditong B0. Okay? So, this is 0, 0. So, this is, so, mag-a-adjust yung sa X coordinate, madadagdagan ng B. So, this is now B0. Okay? So, in this case, we have here this length of this side of the rectangle. And this is now the equation of this line. No? So, yung equation niyan ay y equals A. No? Bakit y equals A? Kasi, at any point, at any value of x, no, ang y mo laging equal sa A, di ba? Ito ay A. Ang distance dyan, ang vertical distance dyan ay A. So, kahit anong value ng x, ang y mo laging A. So, yan ang equation ng horizontal line, no, wherein the distance, the vertical distance from the x-axis to that line is equals to A. No? So, yan ay A. Okay? Siyempre, ang slope niya ay 0, right? So, slope 0. This has a slope equal to 0 because it is horizontal. No? If a line is horizontal, its slope is 0 as you have learned in your previous subjects. No? So, with that, so another thing, so we have the point slope form, no? The point slope form of the line, if you can still remember, no? The point slope form of the line, that is y minus y sub 1 equals to m multiplied by x minus x sub 1. Okay? So that's the point slope form. And in this case, this is x sub 1 and this is y sub 1. So the line passes through this point. Therefore, we can call this as x sub 1 and a as y sub 1. Okay? So therefore, we have y minus y sub 1 is a equals to the slope of the line. The slope of a horizontal line is always 0. So 0 times x minus x sub 1 will become 0. So that's why we have now y equals to a as the equation of this horizontal line. Okay? Now, this distance or this length, okay, is also considered, no? So, which has a length A, okay? So, the height or height of A, and we now consider this area, no? So, we consider this area. We will find now the moment of inertia of this area, no? About the horizontal axis, no? About the horizontal axis, wherein that axis passes through the centroid of that area, no? And that axis is also parallel to the x-axis. Okay. So, we have here moment of inertia about the x-axis. So, ito muna yung ating kukunin. Moment of inertia about the x-axis bago natin kukunin yung moment of inertia about the axis wherein that axis passes through the centroid of the area and that axis is parallel to the x-axis, no? So bago natin kuhanin yon, no? So kunin muna natin yung moment of inertia about the x-axis, no? So ang reference natin ay x-axis. Ano yung moment of inertia ng area na to, no? kung ang reference natin ay x-axis. Okay? So, moment of inertia about the x-axis. Excuse me. So, in here we have the formula for the moment of inertia. So, the moment of inertia, okay, of a certain area, no? So, moment of inertia niyan, no, is equals to the integral of y squared dA, no? So, kaya siya tinawag na second moment of area, no? Actually, pwede natin gawin na integral y times y dA, no? Y times y dA. Okay? So sabihin natin, ito yon. Okay? Sabihin natin, ito yon. Okay? So, sabihin natin yan ay dA, an infinitesimal area, no? A very, very small area, no? So, tapos, ito yung kanyang y na tinutukoy. So, sabihin yan, ito yung reference natin. Ano yung moment of inertia niyan? So, di sabihin, yung first moment, area times y. Diba? First moment yon. Y times dA. Ayun, y dA. No? Yun ang first moment. Second moment, i-multiply mo pa ng y. No? So, y times yung y dA. So, kaya siya second moment of area. So, ang second moment of area, tinatawag ng moment of inertia of an area. Okay? Or area moment of inertia. No? So, in this case, ang concern natin ay plane area. Kaya ito ay plane area moment of inertia. Okay. So, in this case, we have consider natin itong strip na yon sa ilalim. So, itong strip na yan, okay, it has a very, very small area. No? A very, very small area. So, this is an infinitesimal area. No? Itong strip na yan ng rectangle. Okay? Yung actual niyan, yung linya na yan. Ngayon, yung linya na yan, meron niyang area. Meron pa rin area yan. Kung meron ka microscope, makikita mo na parang ganyan siya. Diba? Okay. So, in that case, yung maliit na area na yon, yun ay tatawagin nating infinitesimal area or differential area. So that is dA. Okay? Ngayon, kung dA yan, we have here the distance between the starting point and the end point. So, ito yung starting point, ito yung end point. Okay? So, yung distance na yon, tatawagin natin x. Then, we have here differential y or infinitesimal y, value of y, or infinitesimal height, no? Okay? So, this is the y-axis. So, this is now dy, no? This is now infinitesimal height. Diba? Rectangle yan. Length times width or infinitesimal width, no? Maliit na width. Okay? So, sabihin niyan, ang dA natin ay length times width. So, x dy is dA. Diba? So, with that, okay, we continue. So, yung gaya ng example ko kanina, kung yan ay line, Yung line na yan, meron niyang maliit na length dito sa side niya. May maliit na length na tinatawag natin infinitesimal length, no? So, or infinitesimal distance, no? So, tatawagin natin siyang dy, differential y. Okay? Ngayon, dahil nasa y-axis tayo, yung height na yan may kinalaman sa y-axis, no? Ito. So, in that case, ito naman, mula sa x-axis pataas, yun ay y. No? Yun ang ating y. Mula x-axis pataas. Okay? So, ganyan ang measurement ng y. No? So, from the x-axis papuntang taas. Okay? So, yun ang ating y. Okay? Now, considering that, so yung dA ngayon natin, x dy. Okay? Ito yun. Tapos, yung y na to, yung y squared na yan, okay? So, yung y niyan, dapat perpendicular dun sa area. No? It should be perpendicular dito sa area na to. Okay? So, kaya makikita nyo straight vertical line. No? Straight vertical line siya. Okay? So, it should be perpendicular. So, kaya, we can now proceed. No? Take note, dahil to ay dy, ito yung ating lower limit and higher limit. So, the lower limit here is what? The lower limit is ng is 0. Ito. Dito magsisimula yung y natin. No? Ito yung y sub 1, ito yung y sub 2. Okay? Kasi ang y natin ito, di ba? So, magsisimula siya sa 0. Magsisimula siya sa 0 hanggang umabot siya sa pinakataas. Ayan, sa pinakataas. Ang pinakataas, ang y value mo ay a. Ayun, di ba? Mula 0 hanggang sa pinakataas. So, from 0 to a. Okay? Ganun siya. So, next, we have, so yan, lesson yan sa calculus, no? So, next we have the integral. So, itong x dy, ang x natin ay equal sa b. Diba? Diba ito yon? Yung haba niyan ay b. Ito ay 0, 0. Ito ay b, 0. Ang haba ng x na yan ay b. Okay? So, yan ay b. So, yan ang distance. Okay? So, next we have, so yung p na yan, dahil yan ay constant, we can able to put it to the left side of the integral sign. No? So, kaya meron tayong b integral of y squared dy now. No? Limits from 0 to a. So, integral of y squared dy in calculus, that is y cubed over 3. No? Using power formula. Okay? Di ba yung formula na integral of x to the n dn? Okay? xn plus 1 over n plus 1 plus c. Diba? So, kaya 2 plus 1 over 2 plus 1. So, 3. Okay? So by cubed over 3. So, limits from 0 to a. No? 0 to a. So, then, substitute the upper and the lower limit. No? Kaya magkakaroon tayo ng, so, b is, ano yung b natin? B, ayun. So, magiging, yung B natin ay B. Okay. So, 1/3. So, yung substitute the upper limit, A. Gagawin natin A. So, B A cube over 3 or 1 cube, 1 over 3 B A cube. No? 1/3 B A cube. Tapos, actually, ganyan yan, B A cube over 3 minus B times 0 cube over 3. No? Upper limit, substitute the upper limit and the lower limit. No? Okay? So, kaya, mawawala yan dahil din ay 0. Kaya, B A cube over 3 or 1/3 B A cube. Okay? So, next we have, so this is the centroid of this area. So, yan ang centroid ng area. Considering the centroid of the area, ito ngayon yung axis na tatawagin nating XC-axis. Yung XC-axis na yan, yun yung axis na nagpa-pass through sa centroid ng area at the same time parallel sa x-axis. So, kukunin ngayon natin yung moment of inertia ng area na to, no? Moment of inertia ng area na to about the XC-axis. About the XC-axis. Yun ang ating concern. Anong moment of inertia ng area na yan? About the axis wherein that axis passes through the centroid of that area and at the same time, that axis is parallel to the x-axis. So, para makuha natin yung moment of inertia about the XC-axis, gagamitan natin ang parallel axis theorem. Okay? Parallel axis theorem. So, this is a lesson in engineering mechanics. No? Parallel axis theorem. So, ang parallel axis theorem ay ito. Ix equals to Ixc plus Ayc squared. Okay? So, the moment of inertia about the x-axis is equals to the moment of inertia about the xc-axis. Ito yon, plus the area of this region multiplied by the square of y sub c, the square of the y-coordinate of c. Kasi ang c na yan, may dalawang coordinate siya, xc, yc. Okay? So, xc, yc. So, yung yc ang ating concern. Yung coordinate, yung y-coordinate. At yung yc na yon, ito yon. Ito ay yc. Yung distance mula x-axis hanggang dun sa centroid, yung vertical distance na yan, yun yung y-coordinate na concern natin. Okay? So, yung area ng ating rectangle multiplied by the square of the y-coordinate of the centroid, okay, plus the moment of inertia about the x-axis will give us the moment of inertia about the x-axis. No? So, yun yung Ix. Meron na tayong value ng Ix, the moment of inertia about the x-axis. Ang wala tayo, ito. We will determine. No? So, we continue. So, we can able to determine Ixc. So, by subtracting Ayc squared from Ix. So, arranging. So, we have tayong Ix minus. So, transpose natin sa kabila, magiging minus. So, therefore, Ix equals to Ix minus Ayc squared. No? Next, we have, so ito yon yung tinasabi ko. Ito yung sa YC. No? Yan yung ating YC. Okay? From the x-axis to the xc-axis. So, yung vertical distance, yan ay YC. So, what this is Ix, 1/3 BA cube. Ang area ng rectangle ay BA, right? Ito ay BA. Okay? That's the area of the rectangle. YC is ang centroid ng rectangle. Ang centroid ng rectangle ay kalahati ng buong distance na to. Yung coordinate, yung y coordinate, yung YC, no? Ay kalahati noong kabuuan nito. Ito kasi ay A eh. Kalahati lang. So, kung naaral nyo yung centroid, integration by centroid, no? Centroid integration. Okay? Yung pagkuha ng centroid using integral calculus. Kung naaral nyo yun, malalaman nyo kung paano mag-locate ng centroid, no? Ng isang area. Okay? So, pero sa topic natin, no, yung mga common figure, okay, hindi na natin kailangan mag-integrate dahil common figure naman. So, kailangan na lang na memorize na lang natin kasi common, no? Yung kanilang centroid coordinates. Okay? So, we now proceed. So, this is A over 2. No? This is equals to A over 2 kasi yung ng A. No? So, next. So, we have 1/3 VA cubed minus. So, A over 2 squared. This is A squared over 4. Kaya magiging 1/4. Ayun. B. Tapos A times A squared. Kaya A cubed. So, 1/4 BA cubed. No? Okay. And then, so 1/3 minus 1/4 is 1 over 12. Diba? 1/3 minus 1/4 is 1 over 12. So, common naman yan. Ang LCD ay 12 or using our calculator. No? Using our calculator, 12 divided by 3, 4. So, meron kang 4 BA cubed. 4 BA cubed minus 12 divided by 4, 3 times BA cubed. 3 BA cubed. And we will have an answer of 4 minus 3 is 1. Kaya BA cubed over 12 or 1 over 12 BA cubed. No? So, yun, no? Ganon siya na-derive. 1 over 12 BA cubed. Ito. Pero memorize nyo na lang. No? Pag nag-discuss ako ng problem, dapat memorize nyo na lang. No? Okay. So, we now proceed. No? So, 1 over 12 BA cubed. Next, kung isosceles triangle naman, ito. So, with the base B and height A, no? Ang area niyan ay 1/2 BA. 1/2 times the base times the altitude. Okay? And this is the centroid of the isosceles triangle. Ang kanyang centroid ay ito, mula dito sa, so kung ito ay 0.00, okay, ito yung x-axis natin, okay, at nandito yung y-axis natin, okay, y-axis. So, ang centroid natin ay XCYC. Okay? So, in that case, ang XC natin ay 1/2 B. Ito ay 1/2 B. Ito yung XC natin. Tapos, yung YC natin ay 1/3 A, no? Ito yung YC natin, 1/3 A. Okay? So, na-derive yung mga yan using integral calculus, no? Yung pagkuha ng centroid using integral calculus. Okay? Pero di ko na ang topic yun, no? Sa calculus yun. So, memorize yun na lang, no? Yung mga dinidiscuss ko ngayon na mga formula ng centroid, no? Para sa centroid, x-coordinate is 1/2 b, y-coordinate is 1/3 a, para sa isosceles triangle, no? Okay. And then, so syempre, kung ito ay 1/3 a, nandito yung 2/3 a. So ito yung ito yung point na gitna ng kabuuang area ng triangle natin. Okay? And ang kanyang moment of inertia, using yung mga formula, yung parallel axis theorem, at saka yung moment of inertia about the x-axis, na-derive yan, yung 1/36 BA cubed. Hindi ko napapakita, no? Kung paano na-derive. Hindi naman natin talaga topic yon. Okay? So, topic yun sa previous subject na engineering mechanics at saka calculus 2, no? So, kung meron kang scalene triangle, okay, so, ito yung kanyang base, ito yung kanyang height, no? Okay, BA. So, ang area ay pareho lang ng isosceles, 1/2 BA. So, tapos consider natin yung distance na to. Okay, mula sa origin hanggang doon. And then, meron tayo ditong centroid. Okay, consider natin yung centroid. So, yung centroid na yan, okay, ano yung mga coordinates? Ang coordinate niyan ay, ito yung kanyang x-coordinate. Ito yung ating xc. Wait lang. Ito. Ito yung ating xc. Ayan. And then, yung ating yc. Ito yung ating yc. Yung y-coordinate niya. Okay? 1/3 b plus d. No? Ito, b and d. Then, 1/3 a. So, na-derive yan using integral calculus. Okay, next. The same pa rin, 2/3 a, 1/3 a. No? Okay. So, ito yung kanyang formula, 1/36 BA cubed. No? For scalene. So, kapareho lang siya ng isosceles triangle. Yung kanyang moment of inertia about the xc axis. No? So, moment of inertia about the xc axis. Ito yung ating xc axis. Tapos ito yung ating x-axis. So, moment of inertia niya about the xc axis is 1/36 BA cubed. No? So, then circle. Kung meron kang circle at yung kanyang diameter, ang area ng circle ay pi/4d squared. No? So, ito yung centroid ng ating circle. Yung area ng circle. So, gitnang-gitna. No? So, yun ang kanyang centroid. Okay? Ito yung kanyang x-coordinate. Okay? Ito yung ating x sub c. Ito naman yung ating y-coordinate. No? Y sub c. No? So, ang kanyang moment of inertia about the xc axis, about dito yung xc axis, moment of inertia niya ay pi over 64 multiplied by d to the fourth or pi d to the fourth over 64. Yun ang kanyang moment of inertia about the x-axis. Memorize nyo Okay? Memorize nyo. So, na-derive yan using integral calculus. Then, semicircle. Ito yung semicircle natin. Okay? Kanyang diameter. Ang area ng semicircle ay kalahati ng area ng full circle. No? So, pi over 8 d squared. Ito yung kanyang centroid. Para siyang protractor, no? Okay, centroid. Okay. So, ito yung kanyang x-coordinate. Okay, 1/2 of the diameter of the circle. Tapos, ito yung kanyang y-coordinate. Okay. 2d over 3 pi. Yun ang kanyang y-coordinate. No? Okay. So, take note that yung radius niya ay 1/2 the diameter. Diba? Kalahati ng diameter ay radius. So, ito ay radius. No? At yung pagkuha ng moment of inertia niyan, okay, about the x-axis is 0.1098 r to the fourth power. So, yan ang kanyang moment of inertia about the x-axis. Okay? Then, meron kang quarter circle. Pag quarter circle, yan ang radius. Okay? Ang area ay 1/4 ng area ng circle. No? Pi over 4 r squared. So, kung ito yung ngayon centroid ng area ng quarter circle. Okay? Ito yung kanyang x-coordinate. 4r over 3 pi. X-coordinate. Ito yung kanyang y-coordinate. No? Okay? 4r over 3 pi din. No? At ito yung kanyang moment of inertia. 0.05488 r to the fourth power. No? 0.05488 r to the fourth power. Okay? Okay, so we're done with those topics, no? Na hindi naman talaga part ng ating lesson. Okay? Pero inassume ko kasi na hindi nyo natalakay yung mga yan, no? Kaya binalikan na ni-review ko kayo. Okay? So, in this case, this is our topic, hydrostatic force on a horizontal plane surface. So, actually, na-introduce ko na to before. May problem concerning this topic. No? Hydrostatic force on a horizontal plane surface. So, sabihin natin, ito yung ating object. No? Aquarium, halimbawa, aquarium. Ito ay aquarium, halimbawa. No? And then, so, naka-ano yan? Nakapin sa dalawang points. No? Yung dalawang endpoints, nakapin. Okay? And, para hindi siya para-fix. No? And this is the liquid surface, the free liquid surface. Okay? And we consider the specific weight of the liquid. Okay? We consider the specific weight of this liquid inside this tank. Okay? Ito yung tank. Sabihin natin, tank yan. Okay? the specific weight of the liquid. And we have here the height of the liquid, no? Or tinatawag nating pressure head, no? Pressure head, okay? Kasi pressure head 'yan kung free liquid surface 'to, okay? Free liquid surface ito. Tawag ngayon natin diyan ay pressure head. So pag free liquid surface, ang pressure natin, no, sa atmosphere ay zero gauge pressure, no? The gauge pressure is zero for at the free liquid surface. And consider natin yung yung pressure sa ilalim ng tank. So yan yung representation ng pressure natin sa ilalim ng tank. Okay? So yan ang representation ng pressure natin. Okay? Ang pressure natin sa ilalim ng tank ay simply the product of the two. Unit weight or specific weight of the substance inside this tank multiplied by the pressure head is the pressure at the bottom of the tank. Right? Okay? So yan ang pressure at the bottom of the tank. So next. So the pressure at the bottom of the tank, okay, creates now what we call as a hydrostatic force. So yan yung hydrostatic force ngayon na nag-develop dahil sa presence of pressure at the bottom of the tank. No? Dahil may pressure sa bottom ng tank, magkakaroon ng hydrostatic force. So hydrostatic force is the force due to liquid, no? Due to liquid, force due to liquid, no? So this is itong diagram natin yun na yan, pressure distribution. Okay? Ito yung distribution ng pressure. Okay? Uniform ang pressure natin. Okay? So, sabihin niyan, ang pressure ay hindi nagbabago at any point dito sa bottom ng tank. No? At any point. So, magkaka-height lang sila, oh. So, kung magkaka-height yan, ibig sabihin niyan, ang pressure natin ay constant. Okay? Ang pressure natin ay constant at any point in the bottom of the tank. At the bottom of the tank, no? Pressure is constant. Okay? And hydrostatic force on the bottom of an open tank. So, itong tank natin ay open, no? Take note, no? Consider natin yung area at the bottom of the tank. Ito yung ating bottom view. Area at the bottom of the tank. Okay? Ito yung kanyang bottom view. Okay? Yung hindi natin syempre, 3-dimensional yan. Di ba? 3-dimensional yan. Okay? Hindi natin makikita, hindi natin nakikita yung nandito. Syempre, ito yung sa bottom, no? Okay? Yung bottom view. So, kada point dyan, no? There is pressure. Sa area na yan, kada point, there is pressure. Yan. At yung pressure na yan, nakapag-develop ng hydrostatic force. So, yung hydrostatic force acting at that area. Okay? At syempre, nag-act siya sa center. No? Okay? Nag-act siya sa center. sa centroid. Okay? Alright, so we now proceed. So, yung centroid na to, siya rin yung center of pressure. Yung centroid na yan. Siya rin yung center of pressure. No? Dahil uniform naman ang ating pressure sa bottom ng tank. Okay? So, we now proceed, no? So, this is the area. At ang pagkuha ng force dito sa area na yan is the product of the pressure at the bottom multiplied by the area, no? And the pressure is simply equal to the specific weight of the liquid multiplied by the pressure head H, no? So, actually, na-derive siya dito, P2 equals P1 plus unit weight times H, yung tinuro ko dating formula, no? So, ito yung ating, para sa bottom, meron tayong P. Para sa top, no, pressure at the top, gauge pressure is 0. Then, unit weight of the liquid times the pressure head, no, or the height. Yan ang, kaya na-derive yan, no? Okay, so therefore, ang F natin ay PA, ang P natin ay unit specific weight times H, no? So, the Greek letter gamma times the height or the pressure head multiplied by the area will give us the hydrostatic force on a horizontal plane surface, no? So, that's all for today. Good day, everyone.